Spark and Couchbase, really how you would augment your operational data with Spark. So I don't know, I guess just to get a sense of things, this is the obligatory hand-raising question. Who here is familiar with Couchbase in general? Okay, and now keep your hand up. Now if you're familiar with maybe a different NoSQL database of some sort. Okay, so a good number of folks. So you guys are familiar with the idea that in the NoSQL world, it tends to be a lot of operational data, the data directly behind requests against an application, for instance. And what I'd like to talk with you a little bit about is how Spark helps match that up and a couple of use cases related to that. So we'll talk about why you would do that integration in the first place. Then I'll talk a little bit about some of the architectural alignment, some things that are that apply to Couchbase, and you'll get to learn a little bit about it in the process that align well with parts of Spark. Then we'll talk about some of those integration points of interest. So why do these two things make sense together? And then I'm going to take my own how do I put it? I'm going to take my pride into risk and do a live demo. So I'm going to show you this running here on my laptop, and then I can answer some questions from there. So first, why Spark and NoSQL in general, right? So if you look at the NoSQL world, really what you have happening is you have in the NoSQL world, we're serving web applications to things like laptops and mobile applications. And those are a lot of the places that Couchbase is deployed. Since a number of you probably aren't familiar with Couchbase, you may have heard of something like Viber. Viber is a phone call and messaging application. Their entire back end is actually on Couchbase. So 170 some million subscribers last time I checked. Number of games are deployed to things like Couchbase, but also we have other deployments that are more business-oriented. Amadeus is a recent one where they're really putting travel catalog information onto Couchbase so that they can serve that up very quickly as people are trying to determine, when can I fly from here to there, what is the current price, etc. But there are a few cases like catalogs. Another popular one these days, especially, is Customer 360 and Internet of Things type situations where somebody's trying to build a profile around a user or gather data. Personalization, trying to personalize a site for what a particular user is looking for. And then, of course, all the data behind mobile apps. There's a backside to that, so to speak, right? An analysis piece. If you're talking about cataloging, you're also talking about recommendation targeting, right? So if somebody, there's a side to what the user is using, but I also want to be able to analyze some data and maybe use some machine learning to target them with things that they might be interested in. There's next-gen data warehousing, really where you want to maybe not just understand the current view of the user right now, but what have they been historically. Predictive analytics, I want to take personalization to that next level. I want to be able to predict what is that user going to be in the future, not just personalize where they are currently. So that just gives you a quick sense of it, and NoSQL tends to fit into that left-hand side, which is really the operational data store, and I'll talk a little bit more about that in a second. So just to go a further level to define it, I'm a software developer, and many of you are too, right? Is that you probably have certain attributes about how the system works. Use cases for NoSQL systems in general, and Couchbase is one of those. Operational, web, mobile, like we've talked about, but also things like latency and throughput. It tends to be that when you're building that interactive application, when somebody's making a request from one of these things, you all can probably relate to the idea that, well, if the app's slow, there's a notification, I'm going to go do something else, I've just lost my user, right? So we need to make sure that the operational systems are very low latency, very predictably low latency, very high throughput. Spark, there's another side, before I get to Spark, there's another side which is Hadoop, which is all actually, and I worked on different kinds of Hadoop projects in the past before Couchbase. The reality of Hadoop is you tend to ask Hadoop the kinds of questions that take minutes or hours to run frequently, not necessarily things that you would do in sub-millisecond sorts of latencies, right? So that's that side. Spark has kind of come up a little bit in the middle in that people are doing real, so-called real-time. Anyone who does software engineering knows there's different definition for real time. Whoops. I'll try to keep going here. There are, Spark has kind of come up in the middle in that the kinds of questions that you'll ask of Spark, because you can operate on things in memory, because you're able to deal with large amounts of data very quickly, you'll answer questions in seconds. It's more memory-centric with petabytes instead of disk-centric with terabytes of data, just to give a sense of it. So now that you kind of have a little bit of a basis, what are a couple of use cases? One common use case, seems like I'm still peeking a little. I will whisper. No, I guess not. So one use case would be, as we mentioned, operationalizing analytics. So doing things like machine learning against that data. So for example, you might have situations where you have all of that front-end traffic going against the NoSQL system, and then you'll pass that traffic on to Spark or pull it directly out of the NoSQL system, do machine learning models, build machine learning models that allow you to then do the kinds of prediction that you might want to do, whatever makes sense in that environment. And in this case, you're not reaching into the data warehouse, you're just pulling it straight from the NoSQL system. You want to be able to pull the data out, maybe update the model on a regular basis, maybe update the model on an hourly basis or whatever makes sense for what's happening in the system at that particular point in time. And then you may push that out to a data warehouse or Hadoop underneath to have historical data that you then use to feed your model the next time around. I don't know how much folks are familiar with machine learning, but with machine learning algorithms, you really have to have good training data. You have to have a good set of data to be able to fill out the model. So that's, you're able to get that directly off of that NoSQL system, fill out the model inside Spark, maybe fill the model from other backend systems, and then push those predictions back into the NoSQL system so that as people are operating with the site, you can use those to then target them or offer up other recommendations. Another use case, though, is that Spark actually, a great thing about Spark is it connects to everything. Apache Spark kind of took off very quickly, and it has connectors into almost every system out there. So this is adapted from a Databricks slide where they're showing Spark sort of at the core, that you can work with relational databases, column stores like Cassandra, message queues like Kafka, even full text stores or indexes like Elastic, and MongoDB and Couchbase. And the interesting thing here is with Couchbase, we have a few different interfaces that map very well to things inside Spark. So I'll talk a little bit about that in a second. So, and this is the sort of the entree into that second use case, which is really data integration. The reality of the matter is with any modern complex system architecture, you don't usually master data in one location. So you need to be able to move data around between different systems depending on what you're doing in at a particular point in time. So in that case, you're going to have your operational data. It might not be Couchbase, it might be MongoDB or MySQL or something like that. It might even be Oracle. But you're going to need to be able to move that data to other systems, whether that's HDFS, S3, a different relational database, maybe with a different schema, various different kinds of systems on the back end. And Spark works very well for that. So now I'm going to shift gears a little bit, just so you kind of have a sense of what you can do with these two systems together, NoSQL systems attaching Apache Spark, and then talk about the architectural alignment to the one that I work on, which is Couchbase, of course. So in Couchbase, we have a few different interfaces. We have a key value interface, and that's really just about very quickly fetching data items. Maybe it's a profile for a user as they log into a site, or maybe I'm updating their profile. We have a query service that really allows me to do, specify some criteria. Go find me all the users whose last name begin with I, for instance. And that query service is pretty essential in reporting, even the sort of online kind of reporting that you might do with an application. We also have a Mapreduce Views capability, and this is not the same Mapreduce as you would find in Hadoop. Where Hadoop MapReduce is more batch-oriented. This one's actually an online, always updating MapReduce. And there are some architectural trade-offs for that. But that really allows us to maintain these materialized indexes and aggregations over the data in the system to be able to speed access to being able to say, if I want to query, I don't know, how many people are logged in right now, for example. You can express that in Mapreduce, and it will do the aggregation very efficiently. We also have a data streaming service in Couchbase. So if you want to stream the data out to another system and you want to do that in a very efficient way, that's part of Couchbase directly. And as a matter of fact, that's what we use intra-cluster for maintaining replicas and even cross-cluster for cross-data center replication. But we've exposed that as a public interface, and so that's really useful for being able to integrate with other systems. And then finally, there's a full-text search piece of it. And that's really for the more like the relevance type matching, that if you were to go to Google and you just type something in, and instead of structuring a query, instead of find me all the people whose last names start with I, you just say people whose last names start with I. It's more of a full text search that's relevance based, based on index definition. And the cool thing is that 4 of those actually map up quite well to interfaces that are defined in Spark. The 5th one, full text search, there's a way that we can kind of fit that in, but we don't have support for that yet. So we'll talk a little bit about how those come together. But before I do that, I do want to mention a couple of architectural details. So these are all distributed systems. In the case of Couchbase, one of the things that we do is we hash partition the data across the cluster. And we think that's actually the right model for these kinds of systems that you need to scale very easily. And I can go into just a little bit more detail on that. What we do is within the construct of Couchbase, there's a concept of a bucket. You can kind of think of it like a database. So we'll slice buckets up into logical pieces, and then we map the logical pieces to the physical nodes. And because each one is logical and has a key, each bucket has its own key space, and then we slice it up that way. Now we're able to move that data around within the cluster as needed, so as you need to add and remove resources. And it'll be apparent why I'm talking about that here in just a moment. There's talking a little bit more about the query service in general. That's where we have something called Nickel. And Nickel is actually a superset of SQL. It's so-called kind of SQL for JSON. So you have a few problems sometimes if you're using SQL. For example, in JSON, you can have fields that might be null or missing, and that's a different sort of concept, right? Then SQL will tend to treat things just as null. There are also different constructs, like sometimes in JSON you have so-called triangular data, right? May have an array of objects or an object embedded within an attribute of an object. So you need some keywords to be able to flatten out or to nest those kinds of things together as you're working with them. So Nickel Nickel in Couchbase has its stateless execution, but it uses Couchbase's global secondary indexes. And those global secondary indexes, you might remember I mentioned with key value data, we hash partition it, so we just spread it out across the cluster. But when you get to secondary indexes, if we just spread all the indexes out across the cluster, that would be a really inefficient way to query the system, right? We need to pull that into a structure at one place in the system to be able to query it. Mapreduce Views, as mentioned, JavaScript-based incremental Mapreduce, primarily there for just building sorted B trees. So you can run each one of those on individual nodes, and then we will handle the merge sort at query time. And there are some situations, usually it's things like high throughput into the system that where the Mapreduce views make a little bit more sense. There are some also where maybe you have call it a little bit more flexible of a schema. One of the cool things about NoSQL systems in general, or at least document-oriented ones, is that you can have flexible schema, but sometimes that means that it's a little hard to define an index around it. You need to actually have the capability to write some code to define that index, and that's what this will do for you. And then finally, there's data streaming with DCP. So it allows for streaming all the data out, continuing to stream out what is coming in at the time of connection. So for example, you might have a use case where I just want to stream data as it arrives. I want to stream it out to another system at the same time. Or maybe what I want to do is at 9 a.m. or 9 p.m. I'm going to do a dump of the entire system and put it into another system to be able to do some analysis on it. And then there are a few others for things like transfer and takeover that more apply to the kinds of clustering that we do internally to Couchbase. So with that kind of understanding of the architectural aspects, what about Couchbase from Spark? Well, as mentioned, we've got these 4 different services that we integrate with today. In the key value case, what we do is we'll produce and store RDDs from Spark programs. So there's an interface to Couchbase that just allows you to directly interact with Couchbase key value, whether it's from Scala code or Java code. We haven't done Python yet, but I'm interested in, if you guys have interest, that allow you to access that data as RDDs directly in a Spark program. We also have, Spark has something called Spark SQL, and because Nickel is SQL extended for JSON, we can just plug that into that interface directly. So that allows you to use Spark SQL for accessing Couchbase. There's query against Couchbase for view results as RDDs. I won't spend a lot of time on that here, but if you're interested, let me know. And then there's data streaming, which we will actually see in the demonstration here in a bit, which is exposing data streams from Couchbase through the Spark dstream interface. Okay, so now that we get a sense of what Couchbase is and does and some of the architectural aspects, how do we connect those? In Couchbase, if you're talking about a distributed system, one of the key things is to make sure that you're operating very efficiently, right? And with Spark, one of the ways that we can deploy is you can actually put a Spark node directly on top of the same physical operating system that a Couchbase node is on. When we do that, we actually have the ability to take that accessing of KV, that accessing of those JSON documents as RDDs. We can access them on the local node and operate with them on the local node. So we don't have to transfer everything across the network, so we can operate with very high throughput and very low latency when we're analyzing data. What will happen, and this is all transparent to you as a developer, you just write a Spark program. I don't know how many folks are familiar with Spark, but the awesome thing to me, one awesome thing to me about Spark is that you're writing program logic and you don't need to worry as much about deployment logic, right? So the DAG is generated and executed on the cluster, and we've even taken that to the next level so that if you're KV accessing data, we will work with Spark to schedule that local to the data. So you can just directly access the data locally. So useful for very transformation intensive kinds of situations. However, unfortunately, we don't directly have a way to do that with Nickel and Views because both of those services don't necessarily have that kind of data locality. In both Nickel and Views, Views are the Mapreduce, you end up needing to kind of touch a lot of the data on the system. But I'll talk a little bit about more how we make that operate well with at least Nickel. The other thing that Spark allows for is predicate push down and use of what we call global indexing, global secondary indexes. If you were to crack open Spark, if you're implementing a Spark connector, and so some of this might be interesting for those who are interested in trying to do that, you actually have a few different interfaces to implement. Table scan, which is pretty much what it sounds like, scan all the data and then return it based on if you're implementing Spark SQL, you would have to implement all the details, like again, select where last names begin with I, you'd implement the logic for that. And then return that data. But table scan basically means visit everything, and then Spark SQL will even actually reapply those predicates and filters later. But then there are a couple of other interfaces. Prune scan, which is really where we're able to scan an index and only access the relevant matching data. And then the big one, the one that really gives you a big benefit, is a Prune filtered scan. So this is where you're scanning the index, only retrieving the data that's appropriate to it, and then applying the filter against that and returning that data back to Spark. And so the cool thing is that Couchbase's connector implements a Prune filtered scan. So we pass all of that through to Couchbase query, and then the query language execution will run the optimizer, figure out what best indexes you have, apply whatever filters are there, and pass the resulting data back to Spark. So it minimizes that transfer. Just one note, though, on that, Spark actually reapplies those. So unfortunately, you do have the overhead for reapplying that predicate and filtering once it gets back into Spark, but it's always going to match. We've been talking with the Spark folks about how we might be able to change that in the future to sort of say, well, you can trust this system to apply its predicate and filtering. But there's another aspect to this, which is that if you were to naively, and I did this many years ago, and many of you may have done this. If you were, a naive way to kind of take a single system and make it a distributed system would be to say, do something like sharded MySQL, right? I'm just going to take it and I'm going to shard it up based on a hash or a name value or a range, something like that. And if I query that system, right, if I say, go find me everyone whose last name begins with I, unless I've sharded by that last name field, I now have to visit every node, and then I have to merge sort it. But the cool thing is that in Couchbase, what we've done is we've created something called global secondary indexes. And the global secondary indexes, really what I'm demonstrating here is you can imagine that application client's interacting with the data, that's interacting with the individual data items, and then we use that same DCP feed that we have exposed through Spark to go build the indexes that are defined on the system. And we can store the indexes instead of hash partition, we range partition them on different nodes of the cluster. So the cool thing from that perspective is now when your application goes to query, and whether that's Spark, the Spark connector or something else, goes to query the system, that range query will go specifically, it'll understand what indexes exist in the system, take the most selective index to be able to use, and then it's a single lookup within that index. I don't know how many people remember their operational complexity notation, right? Big O. So if you were to look at that, really what we're doing here is if you were to shard everything up across every node of the cluster, you would have big O log n per node with a fan out of however many nodes you have, where in this case, really what we have is big O log n against the single index. So that means that as you scale up the cluster, the performance remains consistent instead of having to spread everything out. So the cool thing is that we've been able to take, this is just one example, one bit I pulled out of the code, is we've been able to take all of the predicates that Spark defines and push those down to query. And so the query inside Couchbase will actually apply those predicates, and so that's getting just the data over to Spark as we need to be able to get to process the data from there. As I already mentioned, Spark assumes it's getting all the data, so it reapplies them. There are some future optimizations there. So for instance, the Catalyst engine, the SAP has some extensions for that they've been using with HANA. At the moment, that's not necessarily backward compatible, but we're kind of working with the projects and in the open source community to try to figure out where we can go from there. I didn't mention it, but by the way, Couchbase is entirely Apache 2 open source licensed as well. So you might remember there was another service, and that's streaming, so data streams. So with data streams, we do a couple of different things. It's data replication, and we can connect that into Spark streaming. So lots of systems rely on being able to stream that operational data out to other systems. So a good example of that is the so-called Lambda architecture, right, where you're really just handling all the events as they come in, and we'll build indexes over the events to be able to look at that data in different ways. Another example I like to use, this is actually more out of the relational database world, it's kind of Lambda architecture related, is CQRS. And in that case, you're kind of treating your tables as just logs of changes and building indexes as views into them. And then there are different other reactive pattern derived systems and frameworks you might use. So with DCP and Spark streaming, you can kind of picture that as documents are flowing into the system from the outside, we need to send them down to other consumers. That consumer might be Spark, that consumer might be another system. Maybe Spark's just in the middle, as we showed in the second use case, as a way to get it into Hadoop, for example. In many cases, the cool thing here is, unlike traditional, sort of relational, if you were to implement this, I did this many years ago with, say, Oracle. Really, with Oracle, what you would do frequently is you take the archive redo logs, these disk files, and then you move them over to a different system, and then you read these disk files. But here in 2016, we don't really have the time to wait to move files around and open them and read them off of disk. We need to go memory to memory. And DCP does that directly, and it's all event-oriented. So as things arrive at the front end, they're immediately pushed out over a protocol that allows it to very quickly get it to downstream systems. So I know that's a whirlwind of stuff. This typically I would go for a little bit longer, but I want to go through and show it in action. So then that'll maybe make it a little more concrete and answer some questions. So to show it in action, first let me show you what I have here. Let's see. Oops, wrong window. So what I have here, this is a Couchbase console. Every installation has this. This just happens to be running on my laptop. A little bit of trivia. This was actually my first project. Was putting a UI on things. So what I have in this case is it's a pretty boring cluster. It's just a single node. But I have a couple different data buckets. I'll start with one, and then if we have time, I'll kind of show a couple other demonstrations. So I have this bucket called transformative. And my objective here is to do some transformation on the data in that bucket. So you can kind of imagine a scenario where I have a bunch of users, and they're in my operational store. In this case, it's called transformative. But pretend that's called user profiles or something like that, right? And now I get a... Does that tell me I'm out of time? Somebody says, hey, we've got this new partnership. We need to get some data in from this partner onto this system. So really what we're talking about is a database migration of sorts. We're wanting to add a field to all of the records that we have, and we're wanting to connect that to an incoming data set from a different system. And so I actually happen to have a different system here. I have my little MySQL database that has, well, let me do an updated count. So I have 10,002 records from this other system. There's a reason for that, but for the 10,002, I said generate 10,000, and then I had a couple test records. One was me, and one was a colleague of mine. So I ended up with 10,002. So here I have a bunch of profiles. Let's just do a describe profiles. And so what you're seeing here is that on this data input side, something that somebody else has given me, I've got a given name, a surname, an email, and I've got this entitlement token. And the challenge is I want to get that entitlement token into the transformative bucket. Whoop. Let's look at it from a document perspective. So if I have a look at one particular user here, you'll see that I've got a given name, a surname, and an email, but I don't have an entitlement token. So what I want to do is I want to do a couple things. I want to load the entitlement tokens or have reference to them as RDDs from MySQL. And then I want to be able to get a stream from Couchbase of everything, make a decision about whether or not I need to enrich that record with an entitlement token and then restore it into Couchbase. And you can kind of imagine that in a couple of other situations, maybe this is something that I need to do on a daily basis or an hourly basis, or maybe I just want to do it all the time. So let's look at what the code for that might look like. If I were to, let me get into presentation mode. So this is Scala code. We'll kind of start from the streaming side. So really what you're seeing in this particular case is I'm creating a stream. The stream is called transformative. And then, because that's the name of the bucket that I'm retrieving things from. And then I'm creating a filter on it. And the filter basically says, I only want to see things that are mutations because there's some other control messages that might come over a stream. So let's filter out only the things that are mutations. And then I have I map a function over it. What that particular function does is it creates, in this case, I'm actually turning that into, there was one little problem, at least with the version of Spark I was using at the time, and that's that if you have a stream of data that will come in as RDDs and then you're wanting to use DataFrames from an external system, you actually had to work everything with RDDs. So I was converting them into, let's see, in this case I was converting them into RDDs by taking the key and the object itself, and then turning that into a mappable RDD. Then the next section, the filter, what that does is I'm taking everything that has from the stream and I want to connect that to the entitlement token from the RDDs from MySQL. And then for every RDD, I join that. So there's another function here I've defined that will join the data from MySQL with the data coming in from the stream. And then I run this merge into doc function. The reason I wrote a separate function there is just to be able to kind of map the two together. There's also a section here, if I remember correctly, where I filter out the ones that, that's what I'm doing here, is I'm actually filtering out the ones where entitlement token is equal to null. So basically, if it doesn't have an entitlement token, then keep operating with it. If it does, just keep moving on. And then I save it back to Couchbase. So then I'm taking that resulting RDD and storing it back to Couchbase. So the cool thing to me from that perspective is it's really clean logic that's describing what I'm doing. But when I run that, it actually operates on this big distributed system as fast as it possibly can, because we have a high throughput streaming interface, we have high throughput joining and transformation, high throughput storing. So let's try running that. And what we're expecting to see, if we do it correctly, is all of those, if I pop back over to the console, what we should expect to see on transformative as soon as the cluster gets running, this meaning the Spark cluster in this case, we should see a bunch of KV operations as we transform that data. Oh, okay. Oh, here we are. Replicated. That's a thing that I think we can just ignore. In Spark, if you don't actually have multiple nodes, you'll get this warning about it can't be, I'm dealing with data and it can't be replicated in multiple peers. Oh, there we are. Okay, so now you can see we're doing, we only had 10,000 records, and it jumped around a little bit as it loaded data, but we peaked at about 2,000 operations a second here. So after just a little bit, I bet the program's going to be done, right? Yep. Oh, now there's running through the rest of it. I think it's actually done at this point, and because it's the stream continues running, it's basically waiting for me to insert other records. So let's have a look at a record, and if it ran correctly, then what I should have is that each of these users now has an entitlement token, and I went ahead and did that mapping from one to the other. And so sure enough, I've now pulled the entitlement token out of MySQL as an RDD, mashed it up with the data stream coming out of Couchbase, enriched it, and restored it to Couchbase. So what kind of time do we have? 5 more minutes? Okay. I can show one other quick thing. So there are a couple of other, let's jump over to, say, for example, Spark SQL example, because this might be a little interesting to see. So there's another sample data set that's a travel sample data set, and it has a combination of airports and routes and airlines. And so you can imagine, for example, that maybe I want to be able to, from Spark, access data in something like Couchbase, and I want to do it, as mentioned before, in that really efficient way. So what I might want to do, I'm going to go ahead and close this previous one, just to kind of walk you through it. What I'm wanting to do is execute a query. So I want to get some, I want to run a query against Couchbase. In this case, I'm going to select the name and call sign from that travel sample and just limit 100. And Spark has some pretty neat stuff. If you haven't seen it previously, is that it can infer the schema based on the set of data that's coming out of the system. So we can create that data frame by inferring the schema from a couple of things and print the schema out. So Spark will tell us, this is what I found based on the data that I got back in this particular piece, in this particular query. So just running that really briefly. So what we should see is it's going to select name, call sign from travel sample, and then it's going to create a schema filter over anything that is type of airline, and then tell us, for all these airlines, here's what I determine the schema is. We have to wait a little bit for Spark itself to start up. This is just running a Spark one here locally. Whoop. Cannot resolve name to given columns. Well, I guess I won't run that one. Sorry about that. So I should have run that demo before I ran it here. So with that, I want to jump over to any questions, if you've got any. Any questions at all? Yeah.
In that first streaming example that you showed and walking through, I'm just curious which were local methods, which was the Spark API, and which was the Couchbase API?
I can walk through it really briefly. Yeah. So jumping back here. So here, the save to Couchbase, that's a Couchbase method. The SSC Couchbase stream, that's a Couchbase method that's implementing the Spark dstream interface. The filtering, that's actually that's a combination of Spark with the class as defined from some Couchbase Java code. So that's really how it's getting to mutation. Everything else here, let me see, is there anything else? Yeah, everything else there I wrote just directly in the example. So it's in that particular case, it's those two. The complicated piece, actually, believe it or not, when I wrote this sample, was figuring out how to get the stuff out of MySQL. And I did it actually in a relatively basic way. It could be a bit more sophisticated so that you don't store it. You may have run into this. There's one, it's kind of an Uber bug, if you will, is that you can't have a Spark context within a Spark context. So so that sometimes makes it hard to work with a stream where you're also working with another data source, where you want to create a set of RDDs against a data source, and now I want to reference it from a stream. Spark actually doesn't let you do that, or didn't previously. It's evolved pretty quickly. Any other questions?
In one of the implementation, I saw you both Cassandra, Couchbase, and the search. So what kind of scenario you imagine, like Cassandra and Couchbase
In the same system? So that, of course, kind of depends on what your context is, what problems you're trying to solve, but I'll give a quick one.
Background with hospital safety.
Mm-hmm.
So the streaming data is medical information that people to live out their medication, whatever. So I know they write like metadata into Cassandra.
Mm-hmm.
Other data is the elastic search because big query. Also they use Couchbase. I just cannot imagine why they have Couchbase.
Oh, why do they have Couchbase in that particular deployment? Well, so it's hard for me to say exactly, but I'll give you some general sense of it. Cassandra, as primarily a column-oriented data store, it tends to work very well for situations where I have a large amount of data coming into a system and I need to store that data, and it has relatively uniform shape. Think of things like machine-generated data, so maybe things coming off of different systems. Couchbase tends to work well. Where Cassandra doesn't work so well is if you're defining indexes in Cassandra, a lot of that is actually relatively manual. So you're as an application developer kind of saying, well, I'm going to create this other table that is an index of this other table. So you're spending a lot of time on that sort of thing. But where Cassandra's great is it scales well for handling large quantities of data. It's also very reliable to make sure that that data is there at the cost of things like quorum reads. I need to potentially read from multiple places, or you can decide to be less consistent. Where Couchbase tends to work well is the kinds of things where it is that interactive sort of use. So maybe I have a profile around a user or something like that. So I don't know in that exact case, but I can easily imagine that you'd have something like Cassandra or Hadoop or some other system that's just storing all the telemetry. Yeah, so that system might be storing all the telemetry that's ever existed, and then maybe on a regular basis I'm building an online view of the profile of a given patient, for example. So I may I may, kind of relating it to medical, maybe I take blood samples once a week or something like that. I'm going to have a lot of samples, but really what the doctor cares about is what was the last week, or what's the trend or something like that. So hopefully that helps. You and I can maybe talk a little bit after, and I can try to help a little more. I think I probably need to wrap it up, but if you have any other questions, you're welcome to come on up here. Thanks for the time and attention.